I think we can start. Welcome everyone, thanks for coming. This talk will be in English, so I would like to promote English as an industry language, so every programmer should know English. It doesn't matter whether you can speak okay, but at least we should try to speak English so that we can invite more people from other countries to our conference, to our country, etc. Okay, in today's world, it's hard to imagine complex and modern applications without integrations, and this brings integration pain and hell, etc. So in this talk, we're going to take a look at some of the potential solutions that can solve the problem of integration of between complex applications and in microservices world as well. Okay, let me introduce myself. My name is Izzet. I'm a proud father. I have a son, he is 2 years old, and he managed to keep me busy all my spare time and quite sleepy in the morning. I'm working for EPAM for almost 10 years, and my primary programming language is Java. And I'm also exploring for myself functional programming with Erlang, Elixir, and Elm. I'm also passionate about agile, clean code practices, principles, and I'm advocating a DevOps philosophy. That's it about me. Let's go for the agenda for today's talk. First of all, we need to understand the problem statement in order so that we are all on the same page. Then we will move forward to overview solutions that exist to solve our integration problem. We will take a look at several of them, and we will dive deep into one that is called consumer-driven contracts. Then we're going to find the answer for such questions like what is this, why we need it, when we can use it, and how we can use it. And there will be some takeaways and useful links for you to check for more details and link to source code for the demo. And I will try to manage time so that you will have a chance to ask me questions. Okay, let's start with a problem statement. As we know, in real modern applications, especially in microservices world, we have lots of integrations, and integrations mean dependencies. And we need to somehow manage all these moving parts because each application by itself has own life cycle, has own delivery cycle, has own teams that maintains it, etc., etc. So there are many moving parts, and we need to tackle all this. Imagine the situation as an example. We have an application which provides information about company stock from stock market exchange. And this application consists of two services. One is provider, which provides stock price information, and another is a consumer, which consumes this stock price information and returns the data, like information about the company, along with company stock price. At some point in time, we have like two services, and they're exchanging this type of message. So over HTTP, this is JSON, so pretty simple. We have a company name, we have a price, and the price change. Pretty simple, everybody happy, our business grows, and then we have a new client, which requires slightly different information to be returned by our application. So we need to introduce a market capitalization information. But this client doesn't need a change of the stock price. So we have kind of a dilemma. We still need to support our old clients, and of course we need to support the new clients because we want so that our business grows, we have increase in revenue, etc., etc. So this is a problem, and let's try to solve it. Let's take a look also at several cases, like one of these is monolith case. In monolith world, where we have like different modules, they're working together, they share a single runtime. So basically, if we change something in the interface at the compile time, we might discover that there is a broken change and we can fix it right at there. So this situation looks okay in the monolith case. Another case is a microservices case, and this architectural style brings lots of moving parts, lots of services that interact with each other, and they have own dedicated lifecycle, own dedicated team that maintains it, etc., etc. So the situation is worse here, and we need some principles, some solution to fix this problem. And here are a potential solution that we can implement to solve this. First of all, let's try to overview several principles, patterns that can be applied in order to solve this integration pain problem. One is Postle's law, or it's also called as Robustness Principle. This principle, known for the name of internet pioneer John Postel, who wrote the TCP protocol specification. And the idea behind this principle is pretty simple. Basically, we should be conservative in what we send, and we should be liberal in what we accept. It means that the code that like the logic and the interactions that our application does, it should be always like conservative. And what it accepts, it should be liberal, because if something new within like interface, within some new attribute appeared within the message, so we can just ignore it and accept the whole message until this message contains everything what we need. But this implementation of this principle requires an architectural change for our application, because we need to implement it somehow. It also brings obligations for both sides, consumer and provider, because both sides should implement it somehow. And unfortunately, it doesn't provide automated possibilities for contract verification. So we cannot guarantee that two services can work together after some change was introduced. Another principle is called feature toggle. Feature toggle is usually used for like configuring of application behavior, and it allows us to integrate the new features at earlier phases, but it can be exposed to the public only after it is completely implemented. Usually this is done as a configuration of application, but for solving integration problem, we can apply this pattern as well by implementing this in more dynamic way. I mean, to pass some parameter as part of the request to activate some application behavior which is required for this particular client. And another client will send another parameter to activate slightly different behavior. So this kind of solves our problem, but again, this pattern requires architectural change on both sides, because it increases complexity at the provider side, because we need to implement two behaviors for the same interface, for the same endpoint, and it also increases complexity at the consumer side, because in this case, each consumer should know what to pass to the provider in order that the provider responds with correct or expected message format. And it also does not provide capabilities for automated contract verification. And this principle also has some security concerns, because some malicious clients can put something in the request and turn our application to the wrong state. Okay, one more pattern to take a look is called parallel change. The idea behind the parallel change is to split this introduction of a change to the interface into 3 phases. It's expand phase, it's a migrate phase, and it's a contract phase. In the first phase, provider introduces a change to the interface by implementing a new interface in parallel with the old one. And then it proposes each client to switch to this new interface. And this phase is migrate phase. This is actually the longest phase of this principle, where each client should implement some logic at their side to switch to the new interface and forgot about the old one. And then when all clients switch to the new interface, we can decommission the old one, and this phase called the contract. So after this, we kind of done this job. Again, this pattern brings architectural change to both sides, and it doesn't provide automated contract verification. And it increases complexity on provider side because, again, we need to implement 2 behaviors for the same endpoint, for the same logic, but slightly with different messages for interaction. Okay, there is another solution, and this called consumer-driven contracts. The idea behind this principle, it's actually not a pattern, it's a principle, and it's a technique that allows us to share consumers' expectations as a specification for provider, so that provider can verify itself for compliance with this specification. It means that, for example, we have a provider and it calls reverse. We have a consumer and it calls a provider. And it expects that for these parameters, provider returns some specific message. And consumer can share this expectation with provider so that provider can always verify after each change it introduces so that it's still compliant with this specification. And this technique can solve our problem because it's actually just a process change, so we need to introduce this technique into our teams. But again, for consumer and for provider side, it allows us to have automated contract verification because after each change from consumer and from provider, we can verify that we are still compliant with some contracts that were shared between consumer and provider. And one more benefit that brings this technique is actually it unlocks provider API evolution, because after each change introduced to the provider, we can verify that we are still compliant to the contract. Okay, why we need it? Nobody but the consumer knows how it uses a provider. And only consumer can tell to providers that, look, I'm using this and this, and I'm expecting this and this, so please give me this. Another consumer can do the same. So basically, at the end of the day, provider will know how each consumer uses it. And then it can have possibilities to be always compliant with these expectations. One more benefit of implementing this technique is to allow consumer to be tested in isolation from the provider, because we have a contract, and for this contract we can generate stubs. And then we do not need to run all our dependency services so that we can test our consumer it works with a provider. And it also has capabilities for provider to be free in order to introduce new changes to the API, again after verifications that provider is still compliant with a contract. And one more selling point, this technique is actually for more than several years already in adopt phase in the ThoughtWorks technology radar. It means that it is spread within within community, and it is applied by like big companies and startups, etc. So it's safe and it should be used. Okay, one more question that we need to find an answer is actually when to use and to apply consumer-driven contracts. It's a continuous integration, continuous delivery pipeline. So basically, I believe we all in our projects have this, because now it's not just something we like should think of. It's a must-have for each project to have continuous integration and continuous delivery pipeline. I'm not saying about continuous deployment. So consumer-driven contracts verification can be injected exactly in this space. There is a row. So basically, the reason is to inject it exactly at this place because the effort we need to spend for successful implementation of this technique is slightly higher than to implement unit tests or component tests, but it is lower than to implement integration and end-to-end tests. Usually, consumer-driven contracts, they are like implemented at the phase when we have, for example, if we're talking about Spring, when we have a running application and on top of like Spring integration tests. Because in this case, we have a running application and we can mock some behavior so that effort to apply this technique will be low. Okay, if we take a look from both sides, from consumer and provider sides, it also like slightly different phase when this can be injected. For consumer side, usually we introduce a change, we should generate a contract and then verify that we are okay with this contract and then share this contract with a provider. And then at provider side, after each change is introduced to the provider, we need to pull the latest version of a contract and verify that our API is still compliant with this contract. So pretty simple. And now the most interesting part is actually how we can implement consumer-driven contracts for our projects, for our applications. First of all, I would like to overview several tools that exist in the community to implement this technique. First one is called Spring Cloud Contract. It's a part of Spring Cloud portfolio. It provides us capabilities to verify our contracts in automatic fashion. It also generates stubs, and it has a runner so that every time we need to test our consumer, we can run a stub and then verify that our consumer works with a provider, and we can always have a guarantee that this stub is aligned with the contract because it is generated based on this contract. It also has a starter for the Spring Boot so that it's like easy to start with, and there is like small shortcoming. It only supports Java for now. So if you are in the Java shop, so you can use it pretty successfully. There is one more tool that is called Pact. It also provides contract verification capabilities in automated way. It also has a stub generation and a runner, so we can run a stub and verify a consumer in isolation from provider, and we do not need to run all the services that we are dependent on. And one more feature, it's a polyglot. So we have implementation for Pact specification for many programming languages like Java, Ruby, .NET, JavaScript, Go, and even Swift. And it is also in portfolio Pact Broker, which allows us to simplify sharing of specifications between consumer and provider. Actually, Spring Cloud Contract also does this, but it relies on contract to be shared as Maven artifacts through Maven repository. Okay, and this is time for demo. Can you see it okay? Okay, current class is simple stock price controller. We have simple interface and endpoint. There is a stock price DTO that is returned by our controller, and it has parties, price, and stock change of the price. This has simple database just for the sake of demonstration, and it populates some simple data. Nothing interesting here, and here we have test that is implemented in Spock, which actually depicts how our consumer uses a provider. So Pact provides a domain-specific language to describe this usage specification. So we have a chain of method executions. We can define the state of the provider. We can define some description for the usage. We can specify HTTP elements for communication like headers. We can pass the path, which we will call and specify a regex so that there is no hard coding, and provide an example with example call of our provider. Then we're specifying the HTTP method which we'll use to call our provider, and then we are specifying a response that we're expecting from provider to verify that it answers correctly. So we're expecting successful handling of the endpoint call. We're expecting in response some HTTP headers, and we can specify a body in JSON format that we expect to be returned from the provider. And it should contain the price in decimal type, and it's actually quite important to not to tie to some particular values or some particular records within the application, because in this case we have a tight coupling, and if something change, our contract verification will fail, because it not just verifies a contract, but it will verify functionality of our provider. But we would like to have verification only of a contract. So it is important to provide some regex, some types that we're expecting as a response from the provider. And here is similar for the price change. So we have a change attribute, absolute change, and relative change, and we are generating a fragment. And then we are verifying that our provider is actually behaves exactly as we expected. And when this test is run, the Pact specification will be created. By default, it is created in target Pacts folder, and it contains the names of a provider and consumer. And it is pretty simple. It's just a JSON file which has the statement of a provider name, consumer name, and interactions. And this is the most interesting part, because this part describes how our consumer interacts with our provider. So we have the path that we are going to call HTTP method, headers, matchers of our path, response, expected HTTP status code, headers, and bodies that should return our provider to a consumer. So we're expecting some price, we're expecting some price change, and the matching rules. So basically, again, we can see that it's not tied to some particular logic of our application, but it's exactly tied to the contract and to the format of the specification. And there are some metadata. So nothing too interesting here, but we have also, due to the fact that we are using Pact, it has an API for specification of usage of a provider by a consumer for JavaScript clients. So in case if we have like polyglot application where some UI is there, some Java clients, so JavaScript, the UI side can define that it also uses a provider, and it also can define how it uses a provider. So it's pretty similar DSLs that we have in the JUnit. We are defining state, request, response, etc. So not a rocket science, and this is actually like JavaScript. Okay, now as we are remember, we had a request from our business to introduce a change. So we would like to have new response as part of our message, and it should be market capitalization. So we changed our interface, and we need to populate our database with new data. Here we go, we've done this, so everything is okay here. Let's just rerun our application. So everything is okay here. But to verify that our provider is still compliant with all our clients, we need to run this verification step. It can be implemented for your continuous integration server when you're running your build and running tests. So, and Pact also provides a plugin for the Gradle and for the Maven so that we can inject this verification step not just at the unit test level or integration test level, but at into our build. So here's just simple configuration of this plugin. We have path to the how our consumer stock price, stock catalog uses our provider, and we have a specification how our JavaScript consumer uses our provider. So let's just then run our provider verification. It's a simple target that can be run, and we can see it failed. And in a response, we can see that what was changed. So basically, the price change was removed from the interface, and new attribute was added. So it was actually a destructive change because we break our like contract that we shared with from consumer to provider. So right after we like get the latest contract, and right after we introduced a change to our provider, we can verify whether we are still compliant with a shared contract specification. So in order to fix this, we can go back to our source code and to implement our to implement the postal's law principle. So basically, we won't introduce destructive change. We'll just introduce a new attribute like this, and we need to like fill our database. It was wrong. Okay, here we go. So again, everything is okay here. We need to run our price service. Okay, here we go. And we can rerun our verification that after this change, our provider is still compliant with specification. And as we can see, now the problem solved. So after introduction a destructive change, we failed our contract, and we can fix it and verifies that now we support like two behaviors, and new client can use our provider, and old ones, if they implement the postal slow principle, they can still use our service. Okay, that's it about the demo. Let's move forward, and here are some takeaways, the main things that you should remember when you go through this door. So consumer-driven contracts is a kind of a TDD approach, but at the applications integration level. So we can define the contract, and then we can implement it and be compliant with this, and at any given point in time in our software development life cycle, we can verify that we're still compliant. And consumer-driven contracts is a technique which is states for the verification of consumer and provider have a shared understanding of their interaction. So they both know how they interact and what consumer expects from the provider. In case of polyglot shop, you can use Pact because you can specify the contracts in JavaScript, or if you have application files in Swift, and still you can verify your Java backend and .NET backend using Pact capabilities. If you're a pure Java shop, you can use Spring. It doesn't tie to case when you use Spring, so basically it can be used with not just Spring applications. And there are means to share these contracts between consumer and provider. So whether it's a Pact broker, or we can use just simple GitHub repository and pass a URL to our provider so that it can pull the latest version of specification and verify this. Or we can use Maven repository and to share this contracts as a Maven artifact so that provider and consumer can verify itself at any given point in time. Okay, there are some useful links for you to check for more details, because it's not enough time to like dive deep into this topic. There is like definition of what is consumer-driven contracts. The third link is actually quite interesting, especially if you have a microservice architecture style applications. There is like description of testing strategies for this type of applications, links to Pact and Spring Cloud contract. And the last link is a link to source code of the demo. You can clone this repository and verify how it works in practice. And it's time for questions. I believe we have something, right? Yep.
One of these tools provides the ability to track the history of changes of contract.
Not sure. Pact broker has some UI where you can see which consumers use which provider, but I do not remember whether there is like capability to see the history of the changes. But if we are using Git, we can see how it changes.
Thanks.
Yes, thank you. Other questions?
What's the difference? 1, 2, 3. What's the difference? I mean, the core difference between the proposed approach and the stupid, straightforward way of issuing the new versions of the APIs with the next version ID, for example?
There is always a trade-off, right? And we would like to spend less effort and get maximum results. So if anytime we can introduce a new service, but right after this, we need to support both. And
now we have to support both implementations in a single version. So what's the difference?
Well, there is like slight difference because now we know what are our consumers, right? And every time we're introducing a change, but we can verify that we are still compliant. We do not break our consumers. And it's not a matter of like introduction, just a new interface in parallel. It's matter to like maintain this complexity, but to have some guarantees that we do not introduce a break to our consumers.
Okay, and then probably the last question. You mentioned feature toggles, and for the feature toggles, it's a common thing to revisit them in a while and remove the obsolete ones when
Sure.
we know that nobody needs the old logic. Is it the same here? So do we need to revisit the contracts to get rid of the obsolete ones when we know that there are no consumers for the old format anymore?
Yeah, so consumer-driven contracts is a technique, right? And it has some obligations on both sides. So if our application is moving on and we do not need some parts of the data that we are exchanging within our applications, so we can like agree that this is a deprecated thing and we will need to remove it. Then we are like proposing the change at our consumers, and then they will provide the new versions of the contracts, how they use us as a provider, and then we can remove it.
Gotcha, thank you.
Okay, thank you.
How is it linked to some build systems like Maven or Grunt or plugins maybe?
It's actually pretty easy to wrap plugins for Maven and Gradle. And because of Java, you can always implement it using Ant.
And so there are some plugins that
Yeah.
exist? Thank you.
Thank you.
In this case, you combine two different responses for two organizations into single response. But what in case if we have, for example, 10 organizations and we need much more kind of responses?
As a provider, we need to support all of them.
So 10 responses will be included into single one?
Yep. But like, it's again, it's a trade-off and it's a negotiation between the teams whether they really need like this new like attributes. Maybe they can use slightly different service for their purpose or something like this. Because it's not just like I need this, I need this, I need this, and everything will be done just within one endpoint. It makes sense to decompose functionality into different endpoints, different services, different interfaces, and then we can maintain them like easily.
Okay, thank you.
Mm-hmm. Thank you. Okay. Thank you very much. If you still have questions, do not hesitate. You can contact me according to contact details from this slide. And thanks for coming. Hope you enjoy this talk.